So, forward the PPT on my hand. So, what is that? From beginning. Okay. Start. Good evening, everybody. Welcome you all for today's webinar on Introduction to Computer Numerical Control, or shortly called as CNC. This session is mainly aimed to provide a basic knowledge of what CNC is and to provide a comprehensive overview of the CNC technology from its fundamental principles to the practical applications. Whether you are looking at a beginner, just a beginner, or advanced person, this session will let you know about more and more about the CNC operations in the world. Now, what is CNC? What do you mean by CNC? CNC, if you technically tell, CNC stands for Computer Numerical Control. That is, it refers to the automated control of machining tools such as drills, lathes, and mills by using a computer. This is a revolutionary technology. If you say it was started by around 1950 in MIT University. First, when it was not CNC then, it was NC. So what happened at that time? One person had to make some blades, rotary blades. So he was doing it manually and the process was getting too delayed. And for that, what he made? He made into the punched tapes and ran the program. So it was successful. So initially it was the NC, that is numerical control. There was no CNC, it was only NC. It was then later the CNC came into the existence. Now, what are the main parts of a CNC machine? So I told you CNC means computer numerical control. Basically, it means that the unit, the CNC unit, will be controlled by a computer. When I say CNC, it doesn't mean just a CNC milling machine, because CNC means it has many other types also. We have CNC milling, we have CNC lathe, we have CNC grinding, we have CNC wire cut, we have CNC EDM, etc., etc. So basically, all of these things will be the main components to control all this. Are the first thing, it will be the controller. The controller are also known as the brain of the CNC machine. This brain of the CNC machine, what it does, just like what our human brain does, it will accept the program which is given by the programmer. Then this brain interprets all the G codes and M codes, which are the main basic thing in the CNC program. And then these commands will be translated into the physical movement. This G code and M codes will tell the machine what to do. Whether go straight, go left, go right, go into this axis, go up, or else it's like turn on the spindle, turn on the coolant. All those things will be controlled by the controller. The next part is the machine access. Machine access is like normal, just like how we use X, Y, Z axis. This X, Y, Z axis is just like the three movement lines which it goes. So the X, Y, Z. X will be always from front to back. Front to back will be the X axis. Left to right will be the Y axis, and top to bottom or bottom to top will be the Z axis. These are the three-dimensional movement in the machine. This axis always allows the cutting tool to reach any point within the machine's workspace. So whatever the machine bed size is or operational size is, with the movement of these three axes, we move the work. Now in this thing, normal machines we have only 3 axes, but whereas we have some 5-axis machines also. So these 5-axis machines, there will be 5-axis machines will have 2 more axes which will enable the rotation and thus making the works easier, enabling us to do more complex works. Now, next core component is the cutting tool. So cutting tool, what's a cutting tool? A cutting tool, just as the name says, it is a tool that cuts or removes the material. So it can be a rotor bit, it can be a drill bit, it can be an end mill, it can be a face mill, it can be anything. Any cutter which we use to remove the material is called the cutting tool. So these 3 things has to be always kept in mind. Now, how CNC works from design to the finished product. If you see, the first step in a CNC work is the CAD design. CAD means computer aided designing. So CAD design, what we do? So we make the model. We make the model in 3D. So it can be made in 2D or 3D. Even there are softwares, different softwares like you can say all the CAD softwares like SolidWorks, CATIA, NX, Rhino, etc. Creo, and you also have softwares like ArtCam, and all these things where you can do the CAD design properly. From the CAD design, it will be brought into the CAM. CAM is computer-aided manufacturing, and this computer-aided manufacturing software, like you have the SolidCam, you have the Symmetron, you have the MasterCam. We have many other options. So these softwares, what they will do? They will once we make the program, they will convert the program into the G codes and M codes. So that this G code and M code, as I told earlier, will be the instruction set given to the system. So the computer will accept this, and then it will process as per what is the instruction given to the CNC. Now next, once the machine execution. So once the CNC machine reads the G code, it then precisely controls the movement of its cutting tools and the workpiece, progressively shaping the material according to the digital design until final product is achieved. Now, what is the best thing about the CNC? Earlier, we had manual conventional machines. So that time, these manual machines where people use their hand, eyes, we need the hand-eye coordination. So that was very cheap. The machines were cheap. Everything was cheap. But what will happen is when we doing that, when we are doing the same product, when we do the 1,000 pieces of a same product, for example, in such a case, there will be difference each and every piece. We cannot say that the first piece and the second piece will be the same, exactly the same. There will be small dimensional changes. Or we cannot say that first piece and the 500th piece or first piece and 999th piece will be the same. We can never assure that. But whereas in terms of CNC, we are just giving a program, we are loading it, and the machine does all the things. This machine doesn't have fatigue. Machine will not feel tired. Machine will not have human emotions or anything that will be a reason for any errors, any human errors. So what will happen? The product, the first piece to the 1000th piece, or even if you have 10,000 piece, 10,000th piece, or the product will be exactly the same. There will be no changes from the first piece to the last piece. That is the main benefit of the CNC. Second thing, when we do something, when we do it manually, the speed will be very low. Whereas in the CNC, when we do, due to the automation and all, we can save too much time when doing the CNC. Now, what is a G code? So G code, I told you about G code and M code. The machine runs with G code and M code. What is G code and M code? So G code is the programming language that instructs the CNC machine. It's a series of alphanumeric commands that dictate every aspect of the machining process from tool movement to spindle speeds. If you see here, you can see some of the common codes. It's like G01, G00, M01, M03, M05. All these codes, what they do? Basically, these G codes. G codes, what they do is, it will instruct the machine. Go there, come here, go that point, go to this point, take this as a reference. All these points will be given by, and take mm as the unit, take inches as the unit, take this coordinate, take this center. All those things will be given by the G codes. Whereas what will M code do? M code, what it does is, it will tell the machine, okay, turn on the spindle clockwise direction, turn it anti-clockwise direction, or turn the coolant on, turn off the coolant. All these things will be done by M codes. Now, we'll see G01. What is G01? G01 is, they are all G codes. G01 is the code for, it tells the machine that the cutter has to go in a straight line, a linear movement, in a fixed speed. So what will happen? We will just tell the machine, okay, go to this depth. I am cutting the piece. When I remove the piece, when I remove material, move from point A to point B at a feed. So this feed we will decide, we will calculate it. We will calculate and tell, maybe it is 500 millimeter per minute, or 200 mm per minute, or 2000 mm per minute, based on the material. So we will be first deciding that. So with the feed, if it goes, we will give the code as G01. We have the G00 code. What does G00 do? So G00, what does it? It's this code, if you give, the tool will come in full speed, because there is no cutting or anything. It's just positioning. It's a rapid movement. It will come quickly just above the plane which we say, just to save time. Then we have the M03. M03 is for M codes. If I take M03 is the code which we use to turn on the spindle. So normally when we turn on the spindle, we will tell yes is the spindle code. So we will tell yes 8000 M03. That means we are instructing the machine that the spindle has to be turned clockwise direction in an RPM of 8000 RPM. And if we give M04 will be for the spindle has to turn in an anti-clockwise direction. Then we give M05. When we give M05, that is nothing but turning off the spindle. The spindle will be turned off. Now, G28. G28, if you see, it is home position. We have the machine home position and we have the job home position. So G28, it will return the tool return the machine to its home position. So what is S? S I told, it is the spindle speed. And F is the feed. feed to be given. Now see, you can see here, G code is a universal language. So it's a sequence of alphanumeric instructions that tells a CNC machine precisely how to move, what speed to use, and when to perform specific actions, as I explained. So basic G codes, if you see, G00, G01 is a rapid traverse and the linear impulsion, which I explained already. We have the spindle control. Spindle control, we have M03, M05, or we have M6, which is the main thing. M6 is a tool change. If in case the machine has an automatic tool changer, we use the code M6. So we have multiple codes like that. Then next, F. What is F? F is the feed rate. Feed rate is the rate at which the tool has to move during the material cutting. So how we will decide this? We will decide this F based on the material, the cutter used. All these things will be decided, and we will assign a feed rate in millimeter per minute. And G code also, what does G code do? We have the codes to check whether we have to run the program in millimeter, or we have to run the program in inches, or we are telling the machine that we are running it in mm or inches. Such things, everything will be contained in the G code. Now, how to select the right router bits and tools? So, the choice of router bit or cutting tool is crucial for achieving optimal results in CNC machines. Why? Because if you don't use the right tool, your work will not be proper. You will not get a good finish. You will be losing money, because a right tool on a right material, a wrong tool on the right different material will lead to damage of the tool, which will lead to loss of money. Now, bits come in different shapes and sizes. So each thing has each item has specific operations, such as cutting. Some are for cutting, some are for engraving, some are for drilling, some are for surfacing. So first thing we have to think when we select a tool, we have to understand is what is the operation we are going to do. What operation are we going to do? The second thing, as I told, what we have to check mainly is the material and the project type. So what is the material we are using? So we can use n number of materials in the CNC. We can use aluminium. In the aluminium we have different grades, 6062, 6063. Like this, we have enough grades in aluminium, H30. So this aluminium we can use. We can use wood. We can use ABS plastics. We can use EMS. We can use OHNS. We can use HH. Whatever material we use. We can use silver, copper, brass, gold. Whatever material you want, we can use in the CNC machine. So with this, each material, we cannot use the same cutter, end mill cutter, or whatever cutter is. We cannot use the same cutter for different materials. When we select a cutter, we have to use the right tool for the right material. For example, when we do aluminium and we have to use a 3mm end mill, there we'll be using a carbide 3 flute cutters. So there we have to note the flute now, how many flutes are there. There may be end mills with 2 flutes, 3 flutes, 4 flutes, and even more flutes are also available. So, and even we also, there are specialized end mills which have only 1 flute also. So we will decide which tool has to be used there. Then again I told, so carbide is the best for harder materials due to the durability. And now in this carbide we get the coated carbide tools also. That will help in more longevity of the tool. Now, proper bit selection directly impacts the finish quality of your workpiece and the lifespan of the tool itself. Using the correct bit minimizes wear and tear, ensuring consistent results. The same thing, when we use the wrong tool, the finish on the surface will change. Basically, we are getting it for a finish also. So, we need to make sure that we are using the right tool for the right material. Now, see, these are some of the cutting tools which we use. So we have the end mills, we have the drills, we have the taps, we have the reamers. So end mills for removing the material, drills for drilling the holes. We have taps. Taps are for basically for making the threaded internal threads. You can see all these screws and everything. Screw holes. All the screw holes we'll be making with the taps. And reamers. Reamers are used for reaming purpose, where we use when we have to align two plates together. Sometimes we cannot use a screw. What we'll be using a dowel, a thing called dowel, with the exact. The main our concern will be the fit. So we will have the H7 G6 fit. When we need the H7 fit and everything, we use the reamers. Now, what are the key concepts that influence the cutting performance of a tool? As I told earlier, we have to see the cutting speed. So for the cutting speed, how we will do? Each tool will have a different cutting speed. So how we will do the calculation? We have a calculation for that. We use the V equal to pi dn by 1000. There is a formula called V equal to pi dn by 1000, and this determines the cutting speed of the tool. So V, where V will be constant as 25, pi will be 3.14, D will be the dia of the tool, and the N will be the RPM divided by 1000. So once we cross multiply, we will get the exact RPM required for the machine. Then feed rate. So we cannot give the feed rate too much more or too much less. This will lead to finish problems or damage of the cutting tool. Chip load, how much chips is generated, and how the chip removal process, that also affects the cutting performance of the tool. The next is the climb or conventional milling, also called as the up milling or the down milling. On this climb and conventional milling, we can use climb milling or conventional milling or even mixed of this as per our requirement. That's a key concept influencing the cutting performance. Now, how to set a CNC job? So once we got the program, now we got the tools. The next thing, we have to set the job. How should we do that? First thing, always we should ensure that the workpiece or the job is firmly clamped or secured to the machine bed. So, any movement, because if it is not tightened or if it is not fixed properly, there are chances that due to the vibrations or due to the tool movement or anything, the piece may get shifted and the work may get rejected. Now, second thing, we have to, starting point of the cuts has to be given. We have to zero all the X, Y and Z axis. This reference point is crucial for the machine to accurately follow the G code instructions, because we will be telling G01, go to X this value, Y this value. If you don't set a proper zero, this dimension, this reference will be wrong and it won't be proper. Now, next, third one, load G code and verify. Once your G code is loaded into CNC controller, we will check whether there is any mistake. For example, a program is given. We will check line by line. At least initial lines we will check, which we can easily identify whether we have given the right tool number. Maybe we have to give T1 M6. By mistake, the programmer had thought that okay, tool is in another tool. He had given T15 M6. So we have to manually change it to T1, whichever is the tool, actual tool. Then we have to check if the coolant is on, coolant is off. If it is in metric or is it in imperial. if is the height setting proper, if the is the cutter number and the G43 offset is the same. So all these things has to be verified manually by us. Then after that, we will, even if your material is only 20 mm height, we will lift the machine cutter into the set height and make it 50 mm or something, and we will do a dry run initially on the top so that it will not, so that we can verify that there is no much errors. Because once we test the material, once the material is damaged, it's that we cannot recover that lost material, or it may be even damaging the tool. So in order to save that, we'll be running a test or simulation. You can see here some of the common CNC machines. So CNC rotors. CNC rotors will be used for cutting and shaping materials such as woods, plastics, foams, and soft metals. They are widely used in woodworking, sign making, furniture production. Due to the large work areas, they will have a very big base. So what will happen? You can see on this the doors of the houses, or for the gates. All those who want the wooden big statues or mementos, anything, those things will be done in the CNC rotors. Now we have CNC mill. CNC mills are known for their high precision and ability to work with harder materials like metals. CNC mills can create complex three-dimensional shapes, making them indispensable in the aerospace, automotive, and mold making industries. Now then comes the CNC lathes. CNC lathes, they specialize in producing cylindrical parts. They rotate the workpiece against a stationary cutting tool to create components such as shafts, screws, and other symmetrical forms with exceptional accuracy. So whenever it is a round item, we will use CNC lathe. When it is a square item for 3D profiling, we will use CNC mills. And we also have machines like CNC turn mills, where this milling and lathe will be together, and very complex shapes can be easily done. Now, always when beginning, understand one thing. First thing, begin with straightforward projects. So don't go with a complex project immediately. First, learn with small products. Grow from small to big. Then always use the software which is recommended, which is the easiest software, just like how we teach it, just SolidCAM. So once you learn SolidCAM, you can learn any software easily. Now, CNC, what we can do? We can create custom furniture and signage. We can produce intricate artistic pieces. We can prototype new product designs efficiently and engage in small batch manufacturing. These are the main things a CNC can do. So any doubts, anyone? Please, if you have any doubts, please put in the comments. I can clear it here. So if you have any doubt, you can just ask me. If you see about the historical backgrounds, see in 1940s, MIT was the team to develop the first NC machine. Then by 1950s to 60s, they continuously started using the numerical controls, and they were used by punched tapes, just like how we had the CD-ROM or the floppy disk. They had the punch tapes at that time. So that time they used the punch tape. Still there was no computer in the CNC. It was only numerical control. Now, after that, in the 1970s, the CNC was born. The computer was added to the numerical control and then it became CNCs. By 1990, the CNC integrates with CAD and CAM and IoT automation and everything. It is the present situation now. Even robotics have evolved in CNC now. What are the axes? I told you about the axis. Normal axes are X, Y, and Z. In the three-axis machines, they are basic three-axis machines. It will be X, Y, and Z, which are known as the linear axis. Now we have the rotational axis. For the 5-axis machines, we have the rotational axis, which is called as A, B, and C. Now, what are the coordinates? We have two coordinates which we use in the CNC. That is the absolute coordinate, which means it has a fixed reference, and incremental coordinate, which has the relative moment. The main components, as I told earlier, the main components, actually the core components are the controller, machine axis, and cutting tool. But the main components will be the machine structure, which includes bed, column, table. When I tell about column, in the CNC milling, it can be a single column machine or a double column machine, anything. Then we have the spindle and the motor, we have the axis drives, we have the control panel, we have the tool magazine, and the coolant system. Those are the main components of a CNC system. Now, what about the drives and control systems? The drive, we have servo stepper motors for the feed to ensure accuracy. We have the feedback, and the controller, as I told, is the brain of CNC that executes the program line by line. What's advantages of using a CNC? So advantages of using a CNC is, one, we have the precision, we have good accuracy, we have consistency, then automation reduces human error, and it supports complex shapes, batch productions, and we get high repeatability also. Now, programming languages. We told G and M code. G code is the geometrical code, and M code is the machine operation code. So if you have any doubt, please message in the comment box. I will be clearing it. By this, we end the webinar now. Please contact us for the certificates for those who have attended. Thank you.